All right, guys, good morning. Just got done reviewing our measures of variability, the MAD, the mean absolute deviation, that is, the measures of center, and maybe statistical questions. Checked our homework. Today we're moving into dot plots. Um, so let's get after this thing. It's not too bad, but we do have some vocabulary that we do need to go over here, okay? A dot plot is a visual display of data using a number line and dots to represent each data point. The data that represents itself the most often is the mode, one of the measures of center. In a dot plot, the mode is the tallest value. So let's go down here and make a dot plot. And you'll notice at the bottom there's a few dot plots, but this dot plot we're going to take from this data. Now we have to be very careful with this. And I'll tell you why on this frequency table, because it gives us the numbers up here and then the frequency underneath. So, it's just not 1 0, all right, or excuse me, it's just not 1 1 here, all right, and things like that. And you'll see what I mean. So let's go ahead and write down our numbers, number of devices, 0 through 9. Okay. And then let's go ahead and list our frequencies. Over 0 is 1. Excuse me. And over 1 is 2. The frequency is 2, and try to keep your dots spaced evenly. So you'll see what I mean at the end, because we have to look at it and see if it's skewed, if it's center, if it's spread, if it's symmetrical, things like that. How many 2s do we have? Well, we have 4 of them there, so we're going to make 4 dots. 1, 2, 3, and 4. Okay, and I'm going to cross these off as I go. I have 5 3s. 1, 2, 3, 4, and 5. And I have 4 7s. 1, 2, 3, 4, 5, 6, and 7. And I have 5 5s. 1, 2, 3, 4 6s. And 2 7s. And 2 8s. And 1 9. Right? Okay. So there's our dot plot. It used to be called a line plot, where these were just X's. Now they changed them to dots. Not sure why, but it's pretty simple. What do you notice about the shape of the data? List any observations in the space below. Well, what I notice is that if I drew a line right down through here, the data would be balanced. And another name for balanced is symmetrical. Okay, it's symmetrical. This side kind of looks even to this side. All right, your line of symmetry in your body is coming down the middle.
Linda Smith, please call the front office.
Sorry about that. So, so that's what it is. It's balanced. All right, and where would you say most of the data lies on the dot plot? What is the median of the data? Okay, well, I could tell you the mode is certainly 4. That's the most often. And the median of the data, all right, is probably right here. If we were to cross this off as 4. So the median in the mode in this case is going to be equal. So I would say the median, all right, is 4. And that's also the mode, right? Okay. So pretty easy stuff so far, stuff we've been over. Let's continue on. Spread. The variability in the data points describes how far apart the data is from one another. This can be represented by the range, okay? Big minus small. Center. The median and the mean both represent the center of the data. When the data is skewed, then the median is the best representation when it's skewed. Okay, and you're going to see here what that means. When the data is symmetrical, when it's symmetric, then the mean is the best representation of the data. So let's talk about this. So let's talk about the mean. You see, if I was to draw a line here and this side is equal to this, not perfectly all the time, but in this case it is, then what we want to use is the mean to represent the data. But when the data is skewed to the left or skewed to the right, meaning there's more information here or here, then we want to use the median. The median, because that will give us a better measure of center, you see, than the mean. If we use the mean here, it's going to be a lot lower because we have more values here, or it's going to be a lot higher. We have more values there. So just kind of understand what they're asking us there, okay? All right, let's flip the page here. All right. So next up, okay, is more interpretation. We might need our calculator here. So the Ecological Society sampled the green iguana population and made note of the length of each iguana sampled. The data is displayed in the dot plot below. Okay, so, well, we can get this here in just a second. Let's go ahead and take care of these two. These seem to be a little easier. So the range is going to be 19 minus 12, and that is 7's the range. The median, if I go to find the median, all right, and I have to go through my dots, bang, 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 here and here, here and here, and there's the median. And the median is 16, okay? The interquartile range we'll have to get in just a minute, but what is the mean? Let's go ahead and add them up and divide by the total number in the set. I'm going to grab my calculator here, okay? So you'll see I'm doing it right now. So we have a 12 plus a 13 plus 3 14s plus 2 15s, which is 30. You notice you can do that. All right, plus 2 16s, which is 32, plus another one. 2 17s is 34, right? I'm just trying to expedite this. 2 18s is 36 and 1 19. And that equals, that's wrong. For some reason, this calculator does that to me. It's 13 plus 28 plus 14, 15, couple 16s is 32, and another 16, a couple 17s is 34, couple 18s is 36, and 119 is 234. So it's 234, and we're going to divide that by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. We're going to divide that by 15. So 234 divided by 15 is 15 and 6/10. Okay, and that's our mean. So it's 15 and 6/10. All right, so they want us to get the interquartile range. Okay, so we're going to have to write these numbers out, least to greatest. All right, and then we're going to have to go to work on them. That's all. So I have a 12, a 13, 3 14s. And I hope you're not just watching me do this, because when you write it, you're going to remember it. And you're going to have to do this tomorrow on the quiz. You have a couple 3 16s. You have 2 17s, 2 18s, and 1 19. And what I like to do is count my values. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 4, 5, 6, 7. Yep, I'm good. Now, we knew the median was 16 from the dots, right? And we could have done it from there, but the idea is to be more accurate because it's important, right? So we know it. What 16 is it though? You know what I mean? So we're here and we're here, right? So some people like to do this, right? Okay. Others just like to do this. I like to go like this. And there's the median. Okay, so we need to find the first quartile. Don't use the median. We come over here, here and here, here and here. Here's the first quartile. Okay, and let's find the third quartile. And right there. So the interquartile range is 17 minus 14, which is 3. That's your IQR. Okay, so let's take a look at this. It says, based on the shape of the data, which measure of center would best represent this? Well, we talked about when to use the mean and the median, all right? So, to me, is it symmetrical? Yeah, it's pretty close to being symmetrical, so I probably would use the median. But you'll notice that The mean and the median are pretty close. So really, it doesn't matter. But I would use the median here. All right, since it's symmetrical to stick to our rules. All right. Number 3. Okay. What is the peak score of our data? Well, our peak score is certainly 68. It's the mode, right? Okay. The shape of the data distribution is, and we're going to call this what? Well, we'll call this skewed left. Skewed left. If we drew a line down the peak, you'll see that there's more data spread out over here. So we call that skewed left, okay? And when it's skewed, we want to use the mean, right? So what is the range of the score? So, and remember, I'm just going to write mean there just to help me remember. The range is 70. So there's no 74, Mike. There's 72 minus 60 is 12. And that is our range. Okay. So hopefully you're feeling pretty good about this. Not too bad. Label each of the following statements as true or false. A total of 20 homes were rated. Okay, well, let's see. How many dots do we have? 1, 2, 3, 4, 5, 6, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 21. No, that is false. Exactly half the ratings were greater than 66. Okay, exactly half. Well, if there's 20 total, that means there have to be at least 10 here, right? Or it has to be 10. 2, 3, 4, 5, 6, 7, 8, 9, 10. No, that's false. There's more. What's the most common rating? 66? No, that's false. The most common, the mode is 68. So 3 falses there. Okay, and then number 4. Mr. Tips asked his students to sketch a dot plot that was symmetrical and had data that was close together. Which students completed the data correctly? Well, this is pretty easy, actually. So let's take a look at Sarah. So if I drew a line here, that is equal to that. So Sarah has completed the symmetry, and the data is clustered. Nice and tight. Javon, if we drew a line down the middle, that is equal to that. That is also symmetrical, and the data is also tight. So both of them, all right, drew different dot plots, but fulfilled the requirements of what Mr. Tips was asking. Okay. So dot plots today, you got to be able to take data out, get the IQR, mean, median, mode, and the range. Got to talk about skewed left, skewed right. When it's skewed, just remember when it's skewed to the left or to the right, we want to use the mean as the measure of center. When it's symmetrical, when there's a line of symmetry, when one side is equal to the other, then we certainly can use the median as the measure of center, and it would give us a good representation of the data. If we flip it over, you'll see your homework is here. Now, tomorrow we have a quiz. Okay, the quiz will cover the first 5 lessons of the packet. Okay, so we reviewed earlier. This is on there. This isn't too bad. I'm just concerned a little bit about the IQR and the mean absolute deviation. Make sure you're able to differentiate between the two. Have a good day, guys. Bye-bye.